Alright, so we're back with another video. We're on number 38. I want to add all of these, and I can do that. I can start doing it down here. I'm going to skip some space. Log base 10. If there's no base, you assume it's base 10. Log of x times, this is all in the parentheses, I'm going to do times y, and the problem here is I can't do z because it says 3 of those. So I have to do something here before I continue. So what I can do, I can use the property of logarithms that says that this 3 comes up to the power, and then this becomes, there's still the y here, times z to the power of 3, and then I'm done. So what really happened here, this turned into log base 10 of z cubed. Alright, so very similar thing is going to happen over here. They both have the same base, log base 8, which means I'm going to be using these properties of whenever I add logs, I'm really multiplying the insides. So this is going to change into log base 8 of u to the power of 2. Again, this 2 comes up here, and then this 3 comes up here to a power. So it's going to be plus log base 8 of v to the power of 3, and then I'm going to do that property, the product property, I'm guessing is what it's called, the logarithmic product property, or addition property. I'm not sure what name it goes by, but the answer is log base 8 of u squared times v cubed. That was a bad cube. There's a better one. All right, and let's go ahead and box those answers. Box and box. Ooh, got a little bit of lag there. Okay, we're on to this one. We've got some stuff down here. So from here, I need to actually solve this thing, and I need to round. So I don't want just the log evaluating. So minus 8, just doing order of operations, reverse PEMDAS. This is now going to be 4 times 17 to the power of 6x is equal to 12. Now I'm going to divide both sides by 4, divide by 4, divide by 4. And from there, that's going to be 17 to the power of 6x. That's a bad x. 16x is equal to 3. And then from there, I need to somehow do that 3. I'm going to write it a little bit more to the right, give me some room. I need to get this 6x to the base. It's now trapped in the power. So to do that, I'm going to do log base 17, log base 17, and what happens there is the 6x comes down in front, and what is 17 to what power is 17? 1, which is another way of saying that all cancels out. I'm left with 6x is equal to log base 17 of 3, but I can use a change of base formula on this, and that's going to be log of 3 divided by log of 17. Okay, finally I need to divide both sides by 6, and my final answer is x is equal to log of 3 divided by 6 log of 17, and I need to calculate what the how many decimal places that is. So if I come over here, oh, I'm in the wrong browser. There we go. I was not using Wolfram to cheat. Calculator. There we go. I could have just typed it in fast, I suppose. So, log of 3 divided by 6, 6 log of 17, and, ooh, really? Okay, but that is the answer. So 0.064, round to 4 decimals. So 4 decimal places, 0 is 1, 6 is another one, 4, 6, so 0.0646. So approximately 0.0646. And I know that some people might be asking this question, can't I just do log 17 of 3 and then divide that by 6? Well, I mean, if you're using this calculator, which you should be using, you can't do that. And for example, I can not do log base 17 of 3. It says, if I come over here, this does not support that function, and for a good reason. You need to know the change of base formula. Same type of thing, so I'm going to subtract 3, subtract 3, subtract 3. I get negative 63 is equal to negative 2 times 10 to the negative 10x. Divide both sides by negative 2, divide by negative 2, divide by negative 2, and I now get 10 to the power of negative 10x is equal to, that's kind of gross. I'm going to leave it as 63. I'm going to leave it as 63 halves. Oh, no, I'm not. I'm going to change it to 31.5. And then from there, I'm going to take the log both sides, so I should have written this a little bit more to the right, because I need to now come back here and say log base 10, which is I want to do base 10, but if I don't write base 10, I assume it's normal log, so I can write a little bit closer. Log of both sides, and these now cancel out. I'm left with negative 10x is equal to log of 31.5. No change of base formula is needed for this one. Divide both sides by negative 10, so divide by negative 10, divide by negative 10, and x is now equal to all that at log of 31.5, all of this divided by negative 10. We usually type that in, so I'm going to come back here, and it's going to be log of 31.5 divided by negative 10, and that's negative 0.1498. Negative 0.4198. Did I get those correct? I guess I should check. Yep, I got both of them correct. All right, I'm now on to number 42. We need to sketch these, and this is going to be a lot easier on the multiple choice, obviously, because I can just choose one that's correct. But my parent function, so I'm going to follow 2 points around. So my parent function is 2 to the power of x. So what does 2 to the power of x look like? Well, it obviously goes through 0, 1, always, because if I plug in 0, 2 to the power of 0 has a height of 1. When I plug in 1, it has a height of 2. I mean, I could have this point, I guess I could do a half here if I really wanted to. I could go 4, then 8, then 16. If I was being very precise, I would use a ton of dots, but I only need to do 2. It says label 2 points. So those are my initial points. Then the first thing that I see is I have a minus 2. So don't worry about a negative x or a positive x. Always do the 2 first. So negative 2 means right 2. So right 2 means I'm now right 2, right 2. So that was step number 2. I'll label these. That was step number 1. And then from there, I'm going to, if this was a negative x, then I would reflect it over the y-axis, but there's no negative x, so skip that step. Now I need to multiply all the heights by 5. This had a height of 1, over here at 1, now it's going to have a height of 5. So there's my new height. This had a height of 2. 2 times 5 is 10. This had a height of 2, so 2 times 5 is 10, and I come all the way up here. Okay, so that was step number 3. And then finally I need to add 1 to all the heights. So I'm going to come to black, add 1 to the height, add 1 to the height. That was step number 4. Those are the points. And where is the asymptote? The asymptote only moves right there. It only moves right there. So the asymptote moved up 1. So if I were drawing my line, my asymptote, I'm going to do it in black, I suppose. It's going to be right there. So if I were trying to sketch this, it would look like this. It would come down through these points and then get closer and closer that way. Obviously, only these 2 points are clearly marked, so let's go to number 43. My parent function, again, is going to be 2 to the power of x, so 2 to the power of x looks like that, looks like that. Okay, plus 1 means left 1, so that was step number 1. Step number 2 is left 1, so left 1, that's step number 2. From there, I'm not going to reflect over the y-axis. I'm not going to flip this way because it's not a negative. I'm going to multiply the heights by 3, so it was 2, it comes up to 6. It was 1, it comes up to, I should do the different color. It comes up to 6. This comes up to 3, so unfortunately right there, bad placement of the 2. I wonder if I can just grab you guys, and let's move this down here so it's out of the way. And we'll label that step number 3. I know what's going to happen next, so I will move it out of the way. And then finally, step number 4, I need to subtract 1 for the height. So subtract 1, and that is my final step 4. And the asymptote in black again is going to be down here at -1 because it moved down 1 right here. And if I were sketching that, it would look like this. It would come down through here. It should be slightly more curvy than that. So maybe something that looks like that. Close enough. Just closer and closer to the asymptote. Okay. And I think these are our final 2 problems, and then we get the answers. Can we check those answers, see how bad we did? Yeah, I guess when you're checking these answers, you just have to check those points. So up here, we had the point 2, 6 and 3, 12. So 2, 6 is a point, and then 3, 12 is also a point, so we got those correct. And the other points that we had for our other function were -1, 2. So negative 1, 2. Oop, the answer is, so negative 1, 2, which is right there. We got that correct. And 0, 5, we got that correct as well. Perfect. So let's do these final two problems. Do log functions. Okay, so log base 3. Log base 3 of x, that's our parent function. So if you don't know how to graph log base 3, what I would recommend doing is graph 3 to the power of x and then reflecting it over the line y equals x. So I'll do that shortcut method. Well, it's not really, it's a long method, but I know how to graph 3 to the power of x. So 3 to the power of x always goes through this point and then goes up to 3. This is a height of 3. Those 2 points would be reflected over this line y equals x, which goes like that. So if I reflect it over that point, that means I come down here and I come down here. I'm looking through the diagonals of the squares. So for example, the diagonals through the squares right here would give me that point. So that's one way to get those points, but another way is just knowing what that function looks like. I'll go ahead and delete those since they're not going to be needed. But for any log, it doesn't matter what the base is, you will always go through 1, 0. So this point will always be there. And then the next point, you don't know how far to the right to go, so that's where this number comes in. It's going to be a height of 1 always, and then whatever number you have for the base, in this case 3. So that's why we have 3, 1. Alright, so let's go ahead and grab all of you, delete, we don't need you. Okay, so that's our parent function. Those are the 2 points that we're going to be following around. From there, I'm going to go left 1. So left 1 is going to be, oh, we should label that. That was step number 1. Step number 2 goes left 1, left 1, left 1. That was step number 2. And then from there, x is not negative, so I'm not going to flip over the y-axis. Next step, I'm going to check the number out front. The number out front tells me what to multiply the heights by, but that number is 1, so I don't need to do anything. Finally, I just need to shift it down 2. So let me, again, these are always in the way. I'm going to move these to the very top since we're going to just be shifting down. We need this area. So shift all of them down 2. So it goes down 2, down 2, and that is the final step 3. What happened with the asymptote? So normally for our parent function in blue, the normal asymptote is right here through the y-axis. But we had this plus 1, which you remember moved everything to the right 1. So what I would really be doing is I would be moving this asymptote to the right, sorry, that was left 1, and then that would be step 2, and then step 3 would move it up and down, which you can't really do, so I'll leave that in green now. That is our final step for the asymptote, which would mean if I were trying to actually sketch the graph, it would look like this. So it gets closer and closer to the asymptote without actually touching Mr. Sindel. Close enough. And then this comes up this way forever and ever. It's kind of not the best graph, but yeah, it goes like that. Let's check those points. 0, negative 2, 0, negative 2, and I believe 2, negative 1. Yeah, so both these points here and here are on our graph. Thank you, Anna. And our final question for the video, we have this one. So log base 4, we know that every log function goes through here, and that 4 means I go forward to the right, up 1. So that's the parent function. That was step number 1. Maybe I should do step 1 in blue, like put that off to the side. Step number 2 is going to be left 4, so 1, 2, 3, 4, 1, 2, 3, 4, and that was step number 2. Step number 3 is going to be in green, and step number 4, there's no negative x, so I don't reflect over the y-axis. There's no number out front, so there's no height multiplier. It's just plus 5, so I'm going to move up 5. 1, 2, 3, 4, 5, and 5. So that was step number 3. And I can probably actually use technology to say, yep, these actually did move. It's obviously lagging because I'm trying to record a video at the same time. But if I select that 2, I can move it over on top of the yellow points, and select the 1 and move that over the blue points. Okay, those were the 3 steps. What happened to the asymptote though? So the original asymptote, again, it always starts here at the y-axis. So from there we said go left 4, so this gets moved 1, 2, 3, 4, and then that's step number 2. And then from there it moves up and down. That doesn't change the asymptote. That is still here for step 3. That is our final asymptote, which means if I were actually trying to draw a curve, it would look like this. It would come through here, come down, more or less, come down to the asymptote. This one comes up this way. So we need to check negative 3, 5. So negative 3, comma 5 is indeed on there. It's kind of hard to see. It's right in the middle of that square though. And then 0, comma 6 is also on there. So our answer does check out. So I realized that there were some mistakes that were made. In number 30, for some reason, I thought that dividing 6 by 2 was 1/3. That is definitely not the case. So sorry about that. That is actually 3, obviously. I made a mistake for 23. I should have had this x down here in the denominator, but I left it out, which means that I do have another vertical asymptote. Actually, it's not a, it's a hole, actually. So there's no x-intercepts. It's only a hole. So that would be the correction. No x-intercepts, only holes, because you have an x on the top and the bottom. On number 18, I made a mistake as well. This 3x, 3 divided by x, should have been copied down right here, but I did not. So the final answer should have been like that, with an x in the bottom.